Hi, today we are doing problem number 7 for MAC 2311 Engineering from Exam 1, Spring 2011. So number 7 asks us, which of the following functions below has y equals 1/2 as a horizontal asymptote? So we have y is equal to 1/2 as a horizontal asymptote. Okay, and so we're given two functions. F of x is equal to the square root of x cubed minus x all over x plus 4x cubed, and g of x, which is equal to x over x plus the square root of x squared plus 1. Okay, so when we're dealing with horizontal asymptotes, what we want to do is we have to solve for the limit as x approaches positive and negative infinity of the function. Okay, and so we're going to have to solve the limit for both of these to see if they approach 1/2. Alright, so if we do the limit as x approaches infinity of the square root of x cubed minus x over x plus 4x cubed. Well, first of all, if we just plugged in infinity, we're going to have infinity cubed minus infinity over infinity plus infinity cubed, which that really doesn't help us with anything. So what we're going to have to do is we're going to have to simplify this a little bit to be able to get our answer. And so what we want to do is divide by the largest term, or the term with the highest degree of exponent, which in our case is x cubed. And so we're just going to divide each term by an x cubed. So then this becomes the limit as x approaches infinity of, so we're going to divide x cubed by x cubed, so we get 1, minus x divided by x cubed, which is 1 over x squared, all over x divided by x cubed is 1 over x squared plus 4 x cubed divided by x cubed, so it's just 1. Okay, so now we can do the limit as x approaches infinity, because if we plug in infinity for our x, we have 1 over infinity, which we know just goes to 0, right? So this term and this term are both going to go to 0, and so we're left with the square root of 1/4, which we know the square root of 1 is just 1, and the square root of 4 is 2, so we're left with 1/2. So the horizontal asymptote for f of x is y equals 1/2. And so we already know that, so we don't even have to solve for the limit as x approaches negative infinity, because we know that one of the horizontal asymptotes is going to be 1/2 for f of x. And so now we need to figure out if g of x has a horizontal asymptote at y equals 1/2. So we're going to do the same thing that we did here. We're going to do the limit as x approaches infinity of x over x plus square root of x squared plus 1. Okay, and so first of all, what we're going to do is we're going to divide by the leading term, or the term with the highest degree of exponent, which in our case is just x. Because we have this x squared, so you might think that you need to divide everything by an x squared, but you don't want to divide it by an x squared because it's the square root of x squared. So that means the square root of x squared is just equal to x. So we're going to divide each term by an x, which is going to be the leading term. And so when we divide the x into this, we're going to be dividing by an x squared, because if we have an x outside of the square root, then inside the square root it's going to be an x squared, like this. Okay, so then this is going to turn into the limit as x approaches infinity of, so x divided by x, which is just 1, over x divided by x, which is 1 again, plus the square root. And so now we're going to be dividing by an x squared, because although we've been dividing by this x, when we divide by the x and try to put it into the square root, we have to be dividing by an x squared. So if we have an x squared over x squared, which is 1, plus a 1 over x squared. Okay, and so now when we do the limit as x approaches infinity of this, we know that this term is just going to go to 0, right? So it cancels out. And so we're left with just 1 over 1 plus the square root of 1, which is just 1, so all over 2. So this function g of x also has a horizontal asymptote at y equals 1/2. And so we don't even have to solve for the limit as x approaches negative infinity, because we already know that there is a horizontal asymptote at y equals 1/2. And so there could be another one, but all we care about right now for this problem is if there's a horizontal asymptote at y equals 1/2. And so both functions have a horizontal asymptote there, and so our answer is going to be A.